Hello, everybody. Welcome to a smart grasp, explore, and win. Greetings for the day. Let's get started with today's topic. Chapter 3 Playing with Numbers, Exercise 3.1. In that first sum, write all the factors of the following numbers. We are supposed to write all the factors of the given numbers. There are various methods to find all the factors, like tree method, L division method, multiplication method, and also we have division method. Let's try each sum with different method because they haven't given any particular method name. So let's try all the different methods. First subdivision 24. We will start with multiplication method. 1 into 24 equal to 24. 1 we will have 2. So 2 12s are 24. After 2 we will have 3. Therefore 3 into 8 equal to 24. After 3 the next number is 4. 4 6 are 24. After 4 we will have 5. In 5 table we will not get 24. Then after 5 it is 6, which we have already written here. Therefore the number starts getting repeated. Hence we can stop it here. These are the factors. We are supposed to write factors in this way, just to make sure the factors are written in ascending order. Therefore, factors equal to 1, 2, 3, 4, and then 6, 8, 12, 24. By this method, we have covered all the factors of 24. This method is called multiplication method. Moving on to the B subdivision 15. Let's solve 15 using factor tree method. 15 is a composite number, therefore we have to write it in square box. This 15 can be split into 3 5s are. This 3 and 5 both are prime numbers, therefore they have to be captured by a circle. Further, we cannot expand the 3 or 5 because they are prime numbers, so we can just stop it there. Now let's write the factors. Factors equal to 1. We have written 1 is for every number 1 is a factor. It is already known that 1 is a factor of every number. Therefore factors equal to 1. Then the branches of the tree 3, 5 and the top of the tree 15. So these are the factors of 15 and we have solved it by factor tree method. C subdivision. We will solve it by L division method. Let's start. 21, 3 7s are. Next 7 1s are. Now we can write the factors. This method is known as L division method or prime factorization method. Factors equal to 1. Then we have to write all the numbers present here without repetition. Then we have 3 and we have 2 7s, so we will write only 1 7, and lastly we have 21. Therefore these are the factors of 21. Next we have 27. We will solve this by division method, which is just similar to the multiplication method. 27 divided by 1 is 27. Next 27 divided by the number after 1 is 2. But 27 is not divisible by 2, so we can divide it by 3. So 27 divided by 3 is 9. Next 27 divided by, we cannot write 4 because 27 is not divisible by 4. Then we have 5. 27 is not divisible by 5. After 5 we have 6, 7, 8. 27 is not divisible by all the three numbers 6, 7 and 8. Then the next number is 9. 9 we already have here, so we should not repeat it. Therefore we can write the factors in this fashion. Therefore factors equal to 1, 3, 9, 27. Therefore these are the factors of 27. These are the 4 different methods which we can use and solve to find the factors of a given number. I personally prefer multiplication method because We will not miss any factors here since we are checking number by number. Even in the division method, we are checking number by number. The chance of mistakes in the division compared to the multiplication is little high. Therefore, I personally prefer multiplication method. If at all, they didn't mention any specific method to solve. So in this sum, they haven't mentioned any specific methods to find the factors. So it's our wish to choose any of these methods and solve the sums. Since I prefer multiplication method, rest of the sums I will be discussing using the multiplication method only. Now let's discuss E sum. 12. Let's start with 1. 1 into 12 equal to 12. The number next to 1 is 2. So 2 into 6 equal to 12. After 2 we have 3. 3 into 4 equal to 12. Now after 3 we have 4 which is already written there. Hence if you write the 4 table then it will be a repetitive. Therefore we can stop it here. Factors equal to, we are supposed to write it in this fashion so that the factors are in ascending order. 1, 2, 3, 4, 6 and 12. F sum 20. Let's start from 1. 1 into 20 equal to 20. After 1 we have 2. So 2 tens are 20. After 2 we have 3. 20 is not divisible by 3. So let's skip it. After 3 we have 4. 4 5s are 20. After 4 we have 5 which is already written here. Therefore we can stop and write the factors in this fashion. Factors equal to 1, 2, 4, 5, 10 and 20. G sum, we have 18. 1 into 18 equal to 18. After 1 we have 2. 2 nines are 18. Then we have 3. 3 6 are 18. After 3 we have 4. 18 is not divisible by 4. After 4 we have 5. 18 is not divisible by 5. After 5 we have 6 which is already written here. So let's stop it here and write the factors in this order. Therefore factors equal to 1, 2, 3, 6, 9 and 18. Moving on to the H sum 23 which is a prime number. So we can straight away write 1 into 23 equal to 23. Actually we can straight away write the factors of a prime number because we already know that 1 and the number itself are the factors of any prime number. Since we are supposed to solve it step by step, let's write the multiplication. That is 1 into 23 equal to 23. After 1, this 23 is not divisible by 2, 3, 4, 5, 6 and it goes on till 22. It is not divisible by any of the numbers because it is a prime number. It is divisible by its own table. Therefore, factors equal to 1 and 23. I sum 36. Let's start with 1. 1, 36 are 36. After 1, we have 2. 2 18s are 36. After 2, 3. 3 12s are 36. After 3, we have 4. 4 9s are 36. After 4, we have 5. 36 is not divisible by 5. After 5, we have 6. 6 6 are 36. So the 6 is repeated here. Hence, we can stop it. Then we can write the factors in this fashion. Therefore, factors equal to 1, 2, 3, 4, 6. We can leave the 6 to avoid repetition. 9, 12, 18 and 36. Therefore, these are the factors of 36. Now let's discuss the second sum. Second sum, they have given 3 subdivisions and have asked us to write the first 5 multiples of it. Multiples in the sense we are supposed to write the values which come in its table. The first 5 values that comes in its table is what is asked. So let's start with the first subdivision. Let's write the tables just to find the first 5 values. 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20 and 5 fives are 25. They have asked first 5 values alone, so we can stop it here. Therefore, multiples equal to we will write these values 5, 10, 15, 20 and 25. Similarly, second subdivision, 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32, 8 fives are 40. Now let's write these values. Therefore, multiples equal 8, 16, 24, 32 and 40. Now see sum 9. 9 ones are 9, 9 twos are 18, 9 threes are 27, 9 fours are 36, 9 fives are 45. Therefore, multiples equal to 9, 18, 27, 36 and 45. See some match the items. They have given column 1 and column 2. We have to compare and match the right answer. In the column 1, the first value is 35. Let's compare it against each option. The option A is multiple of 8. 35 is not divisible by 8. In the 8 table, 35 will never come. Therefore, we can ignore that option. Moving on to the next option, multiple of 7. Yes, it is, because 7 fives are 35. 35 is divisible by 7. Hence, we can choose the option B. The reason being 7 fives are 35. Now let's go to the second subdivision, 15. Multiple of 8. 15 is not a multiple of 8 because it is not divisible by 8. In 8 tables, 15 will not come. Moving on to the next option, multiple of 70. Multiple will always be equal to or greater than the given number. Obviously, 70 is a greater number than 15. Therefore, it is not possible. The next one is factor of 30. Now, this is true because factors are the numbers that is equal or lesser than the given number. Also, 30 is divisible by 15. Therefore, 15 is a factor. That is, in 15 table, 30 will come for sure. Therefore, option D. The reason being, 15 twos are 30. In order to have better clarity, let's take the multiple and factor comparison. As we have already discussed in the concept video, that is, if m is a multiple of a number n, it means in the n table, m should present. Same ways, if f is a factor of a number n, then in that f table, n should be present. In the first case, we have 35. So 35 is a multiple of 7. That means in the 7 table, 35 should present. For the second example, we can consider second subdivision. 15 is a factor of 30. Therefore, in the 15 table, 30 should present. This is the basic concept. In order to simplify it further, any two numbers, let it be multiple or factor or whatever it is, in the any two numbers, we will have a smallest number and a highest number. The smallest number should be the factor and the highest number should be multiple. So in the third subdivision, we can take 16 and 8. 16 is the highest number. It should be the multiple of 8. Therefore, third one option is A. That is 8 twos are 16. We can relate it with the smallest highest concept also. 16 is the highest number, therefore it is the multiple of 8. 8 is the smallest number, that is the factor of 16. Now fourth subdivision, 20. The left out option is multiple of 70. 20 and 70. In 20 table, 70 is not present, so we can ignore. Factor of 50. On comparing 20 and 50, 50 is not present in 20th table. Now moving on to the last option, factor of 20. Yes, 20 is a factor of 20. Therefore, option F. The reason is 20 ones are 20. We can compare the highest and lowest concept also. We have 20 and 20 both are equal. 20 is a factor of 20. 20 is a multiple of 20. Hence it is satisfied. Fifth subdivision 25. We have two left out option multiple of 70. In 25 table 70 value is not present. Therefore we can ignore that option. The next option is factor of 50. On comparing 25 and 50, 25 is the smallest number, 50 is the highest number. So 25 is the factor of 50. 50 is the multiple of 25 because smallest number is always factor, highest number is always a multiple. Therefore, it is satisfied. Hence, the option is E. The reason being 25 twos are 50. Fourth sum, find all the multiples of 9 up to 100. We have to write the multiples of 9 like this. Here we have written till 45 only, but we are supposed to write till 100. When the multiple reaches till 100, we are supposed to write. So let's try the 9 tables. 9 ones are 9, 9 twos are 18, 9 threes are 27, 9 fours are 36, 9 fives are 45, 9 six are 54, 9 sevens are 63, 9 eights are 72, 9 nines are 81, 9 tens are 90, 9 elevens are 99, 9 twelves are 108, which is greater than 100. Therefore, we are supposed to ignore this value alone and we can write the rest of the values. Therefore, multiples equal to 9, 18, 27, 36, 45, 54, 63, 72, 81, 90 and 99. With this, we have completed this exercise.
Thank you all for watching Smart. Grasp, explore, and win. Stay tuned for more videos.